It is needed later on. So please, can you start doing question one? Question one, which you don't have the sheet with you. This is question one. So you have a random sample from this density function. The question is to find the MLE, or the maximum likelihood estimator of sigma. Okay. So I'll give you about 10 minutes, okay? All right. And of course, if you have questions, feel free to, you can use your microphone or you can use the chat box. Either way is fine. All right. Um, Hello guys, you okay? Um, so can you, if you just joined me, can you do question one, please? So you have a random sample from a PDF as given to you. And you're asked to find the MLE. Okay, okay. All right. And so this is, once again, this is the question. As I said, this is not related to the stuff we did this week on Tuesday, but is needed for what we will do later on in this course. So that's why I gave you this kind of questions as a tutorial for this week. Okay. If you need any help, please use the chat box or use your microphone. Either way is fine with me. Okay. All right, let me show you how to do question one if you haven't done it. I'm sure most of you have done it. So to do question one, let me change the camera. If the camera needs to be changed, I guess. To this. Okay, here we are. So this is question one. So the first thing you must do is to write down the likelihood function, which is just the product of I from 1 to n of the density function, which is 1 over sigma e of minus xi by sigma e of minus e Okay, so this is the likelihood function. Now simplifying the product, you get 1 divided by sigma by n e minus 1 over sigma times the sum of xi, and then you get e minus the sum of right. Okay, you get that. Okay, then the next step is to take the log likelihood function, which is the log of L sigma. So this is going to be minus n log sigma minus 1 over sigma times the sum of xi minus the sum okay. So this is the log likelihood function. Then you take the derivative with respect to sigma, right? W2 with respect to. So you get d log L sigma by d sigma, which will be minus n over sigma plus 1 over sigma squared times the sum of xi minus 1 over sigma squared, sorry, correct me if I'm wrong, but minus 1 over sigma squared times the sum of xi minus xi divided by sigma, right? So the MLE of sigma is the root of the equation that this is equal to 0, right? And if you set this equal to 0, you will get the following. You will get the n sigma equal to sum of xi minus sum of xi okay. Okay, so this is obviously you cannot solve this. This equation cannot be solved analytically. So the answer. So what you must write down is that this must be okay. This must be solved numerically. So using the computer program for sigma hat, the MLE for sigma. All right, guys. So this is clear to all of you. Any questions you have? Hello, guys. Are you okay with this or not? Yeah. Any questions, guys? No? Let me know if you have questions. So this is the solution. I mean, yes. Well, there's one question. Yeah. You can actually check whether the solution of this equation is indeed a MLE. And to do that, you need to find the second order derivative of this and make sure that the solution of this equation corresponds to the second order derivative being less than 0. It can be done, yeah, but I hope you can do it yourself. So yeah, that's a good question, guys. So just to make sure that the root of this is an MLE, you find the second order derivative of this and make sure that whenever sigma is given by this equation, you have a negative sign for the second order MLE, second order derivative. I think that shouldn't be difficult to do. It shouldn't be difficult to do. Okay. Yeah. All right, guys. Any other questions you guys have? All right. If not, can you do a question 2, please? Question 2 on the tutorial sheet. which you should have with you. I mean, I'm recording this session, so after the tutorial, I will update the course web page and also the YouTube channel so that you can see the full solution in different formats. Right? I mean, I think you will see 4 different formats of the solutions after this tutorial. All right, guys, can you please do so let me go back to okay, so here we go. This is question 2. And so here you have 2 parameters, lambda and sigma. Okay, so I'll give you a few minutes and see. I'm sure some of you have already done it. Yeah. Yes, you can. Yes, one question asked me, sum of xi can be written as n times x bar. Yeah, you are right. Yeah, you can write as n times the sample mean. Yeah. Okay, guys. Any other questions? Feel free to use the chat box. I'll give you a couple of more minutes and then I'll show you how to do question 2. Okay. All right, guys. Okay, let me show you now how to do If you haven't done it, I mean, so I'm sure most of you have done this question. So if you haven't done it, let me show you how to do question 2 now. Okay. So the first thing to do is to write down the likelihood function, which is a function of two parameters, lambda and sigma, and is the product of the density function 1 to n of lambda sigma power lambda xi minus lambda minus 1, then e of minus sigma power lambda xi power minus lambda. Okay, so this is the likelihood. Now if you simplify this, you will get this lambda n right. So this is the simplified likelihood function. And the next thing is to take the log likelihood. Right, so it's going to be the log of then minus lambda plus 1 then minus the sum okay. So this is the log likelihood, and then you need, because you have two parameters, you need to take the partial derivatives. So the partial derivatives with respect to lambda and sigma are as follows, right? So let me first of all let me find the partial derivative with respect to lambda. So there's going to be n divided by lambda plus n log sigma minus the sum of 1 to n of log of xi, right? And when you differentiate this, you need to be a little careful. I'm sure you've done your calculus. I'm sure you guys probably know more than me. When you differentiate this with respect to lambda, this is what you will get. Okay, so this is the partial derivative with respect to lambda. And let me set this to 0, and for later purposes, let me call this equation 1, right? Now, the second is the partial derivative with respect to sigma. That's going to be n lambda by sigma minus Set this to 0 and call this equation 2. Right? Are you guys okay so far? Any questions? All right. Now you can simplify. I mean, these two equations once again cannot be solved analytically, but you can simplify them a bit. So that's what I expected you to do. So from equation 2, you will see that right, you will get this, and this, which implies that in turn that sigma is equal to this, right? So using equation 2, you can express sigma in terms of lambda, which is a good thing. So let me call this equation 3, right? Now if you substitute 3 into 1, right, you will get the following. A few things will cancel out. I think I'm sure you guys are good enough to do this. So if you substitute this into this, right, you will see a few things will cancel out, and you will get the following equation. All right, this is what you will get. You see, this is a lot simpler than this equation. So what I've done is to substitute this into this, and it simplifies to this. And let me call this equation 4. Now, if you look at equation 4, there's only one parameter, there's only one unknown variable in equation 4, which is lambda. So you can solve 4 to get lambda hat, right? Now, once you got lambda hat, the MLE for lambda, then you substitute lambda hat into 3 to get sigma hat, right? Okay, so it's not, I mean, we have simplified a bit. So the only thing you need to solve is equation 4, which involves only lambda. And once you solve lambda or lambda hat, which is the solution of equation 4, we go back to equation 3. It gives you immediately, you should replace lambda by lambda hat on the right hand side of equation 3, you will get sigma hat, right? Okay, so this is what I expected you to do. I hope you have already done this, right? Any questions on this, guys? Any questions, guys, on this? So what I expected was to write down the likelihood equations and also try to simplify them as much as you can, and that's what I have done here. You should see. Okay, you guys okay? All right, can you do the next question, please? Question 3. If you're okay with this, can you do question 3, please? All right. You guys, if you have any questions, please feel free to use the chat box or talk to me using your microphone. Okay. So the next question is question 3, which is this one, right? Similar to question 2.
充电的那个，它是 Type C 的，但是我没有 Type C 的那个插头。
MacBook 不是 Type C 的插头。
对啊，就是还好有 MacBook 的这个插头，不然我连它都充不了电。
这个我想到了，我当时还想着这个东西如果那啥，但是当时你说你买了这个电脑，我说那刚好还有这个插头可以插。
我觉得 MacBook 这个充电器还蛮好用的，就是普通的充电器那样，看看。
呀，你一说这个我还愣了一下，我还以为 MacBook 不是 Type C 的，吓我一跳。记得那个电脑就是 Type C 的口，然后那啥 AirPods。
You guys okay? Are you doing question 3, guys, now? Yeah, please feel free to write to me if you have questions. Okay. Oh, may I look in the top half of the question 2 again? Oh, okay, sorry. Yeah, okay, let me show you. Okay, after the tutorial, I will post to you 4 different solutions for all the questions in this tutorial. But okay, let me go back to the camera again. Oh yeah, this is the solution to question 2, which I just wrote down. Okay, if you want to see it in full, this is it. Can you see it okay, guys, now or not? Okay, guys. All right. Are you working on? Anybody wants to see the full of this? I mean, I will post a copy of this online after the tutorial. So I mean, so you can see it later on in a few after 3 p.m. UK time. Okay. Right. Okay. Now let's look at question 3, guys. Now question 3, which I just asked you to do. Okay. The question 3 is similar to question 2. So the first thing is to write down the likelihood function. So once again, you have two parameters, lambda and sigma. All right. Now you should take the product of this. If you take the product of this, this is what you will get. Right. So this is the likelihood function. And the second step is to take the log. The log likelihood is going to be the log of this. So it's going to be n log lambda minus n lambda log sigma plus lambda minus 1 times the sum of log xi and then minus sigma okay, so this is the log likelihood function. And the next step is to take the partial derivatives. The partial derivatives with respect to lambda and sigma are as follows. So first, with respect to lambda, so if you differentiate this with respect to lambda, you get n by lambda minus n log sigma plus the sum of log of xi. And the derivative of this, you have to be a little careful. It's going to be the following. All right, so this is the partial derivative with respect to lambda. Let me call this equation 1, right? Okay, next, the partial derivative with respect to sigma is going to be this one. Let me call this equation 2, right? It's very similar to the previous question, guys. Okay, Jatin. All right, let me explain how I differentiated this. I mean, the derivative of this with respect to lambda. Do you guys remember? Let me use a different color. Just give me a sec, guys. Find my pens. All right, here we are. All right, so the rule for differentiation I have used is this. So suppose you have when you differentiate x to the power lambda with respect to lambda, the rule is this. Do you remember this from your calculus? This is what I have used. This is what I used over here to get this term. Okay. I hope you remember this from your calculus course long time ago. All right, and the same rule I used in the previous equation, right? Okay. All right. Okay. Now from equation 2, you can solve for sigma in terms of lambda. So you will get the following. All right, so that's here we are expressing sigma in terms of lambda from this equation. So let me call this equation 3, right? Now if you substitute 3 into 1, right, and do some simplification, right? I'm sure you guys know how to do the simplification. Afterwards, you will get this. Oh, sorry, this is, excuse me, Patrick, just a minute. Yeah, this is x to the power lambda log of x outside. I'm sorry for not being clear. So it's x to the power lambda is one term, log of x is another term. Okay. Okay, so you will get thank you guys. So if you substitute 3 into equation 1, this is what you will get after some simplification. All right, let me call this equation 4. Now, if you look at equation 4, there's only one unknown thing in equation 4, which is lambda. So you should be able to solve this easily using a simple program. Okay, so you can solve for to get lambda hat, right? Once you got lambda hat, you substitute lambda hat into equation 3, right? To get sigma hat, all right? So this is this is the solution for question number 3. You guys okay with this or not? So similar to the previous question I did. All right. You okay? I hope you can see this. I mean, if you want the top part, this is the top part. But I'll post the solution in a sec, so don't worry. All right, can you now do the question 4, the last question, please, which shouldn't be difficult. Question 4. Okay, guys, can you do question 4, please? All right. Let me change the camera. All right. Anyway, keep it this way. So I'll show you. We have 10 minutes left, but if you have any question, just feel free to ask me. So this is question 4. Question 4 should be easy because you only have one parameter. So the first thing to do is to write down the likelihood function, which is L of lambda equal to the product all right, and this can be simplified as the product I from 1 to n everything raised to 1 over lambda minus 1. All right, so this is the likelihood function. So then you take the log. The log is gonna be the following. right? And then you take the, because you only have one parameter, we just do the ordinary derivative. So the derivative with respect to lambda is the following. Okay. Minus 1 over lambda minus 1 times the sum 1 to n of xi divided by xi. Okay. All right. So once again, this equation, I mean, so you set once again the MLE of lambda is the root of the equation that d log lambda by d lambda equal to 0, which is the same as saying, you can rearrange this a little bit, which is the same as saying that the sum 1 to n of log of 1 minus lambda xi is equal to lambda minus 1 times the sum of xi divided by 1 minus lambda xi. So this equation clearly cannot give an analytical root, so it must be all right. Okay, so it shouldn't be too difficult to solve this, right, numerically. And once again, you can verify whether this is an MLE by taking the second order derivative of this and making sure that the second order derivative when this falls is negative. It shouldn't be too hard to do. Okay. All right, guys. Any questions on this, guys? Yeah, you guys okay? Right. So after this, I will post the solutions on the course website and also on the YouTube channel. I will give 4 different versions of the solution. One is the typed solution. The other one is the handwritten solution, which I've just done. The other one is the video solution, which I well, there are two types of video solution. One is the one that I just recorded, but I also recorded a video solution myself with my own time of this solution. So I will post the two. So you will have 4 different versions of the solution for each tutorial. I hope you like it. Okay. And for next week, week 2, please could you look at the playlist for week 2, right? You know where to find it, right? Please look at the playlist. I think there are 5 There are 5 videos on the playlist for week 2. So please listen to those when you have time. And when I see you guys on Tuesday next week, I will just summarize what is in the 5 videos and also try to do some examples next Tuesday. Okay. Okay. All right. Thank you guys. I would have a good weekend. And if you have any questions, as always, please you can contact me 24/7, right? By email, by phone, by Skype, by Zoom, or anything. Okay. Okay. Have a good weekend.